Now that we are getting more comfortable with availability, we also need to identify availability in a form that is usable. Generally speaking, availability is the instantaneous value, the long-term average, or averaged over a certain duration. Here in this module, we'd look at the most typical representation of availability in terms of mean time between failure and mean time to repair. We'd look at the availability of components and services and how the availability of components is different from services. And we'd look at an example. So here we are looking at the averaging of availability. Availability in terms of mean time between failure and mean time to repair is actually a ratio of the total uptime and the downtime. The uptime is actually the mean time between the failure when the system is actually usable. When the system is down, it is going to be repaired. So that particular time is known as mean time to repair. Now, if we are looking at the availability of network components, then we can define terms as mean time between failure and mean time to repair. But if we are looking at services, then equivalent definitions also exist, such as mean time between service outage and mean time to recover from service outage. The typical value for mean time to fail is once per 4,000 hours or 166.7 days. Now, this is empirically proven for the organizations which survive. Now, here, although I have made a quick running mention of mean time to fail, later we'd look at a relationship that exists between mean time between failure and mean time to fail. The typical acceptable mean time to repair in competitive organizations is less than 1 hour. So if you look at, let's say, 6 months duration with 1 hour for repair, the availability is going to be 99.98%. The mean time between failure, along with mean time to repair, these actually help us to assess the frequency and length of service outage. Although we are considering mean, but we must also take into consideration the variance. If the variance is too high, it means that we need to do some other mathematical treatment to make it more usable. As I said, there is a fine difference between two concepts which are interchangeably used. One is the mean time between failure, and the other one is mean time to fail. Just to put it in simple words, whenever a component fails and gets restored, we refer to it as mean time between failures. But if a component fails and it needs to be replaced, then we use the concept of mean time to fail. Let's look at this figure. This shows us the uptime and the downtime of a certain network. We see that what is shown to you in blue is the duration between the failure happens. And when a failure happens, then you see that we have the failure shown as when this particular waveform is in low state or in off state. So we see that in this instance, how many uptimes do we see? We see 3 uptimes and we see 3 downtimes.